Okay, let's take a look at this lesson. 3.4. Thank you. So here, rates of change in the social sciences, we're going to look at cost, revenue, profit, and their derivatives and what they mean. So here we go. If c of x is a cost function, that would be, thank you, c represents the cost, and x would be the number of units of whatever you're making. So the cost is a function of how many things you're producing. All right. So the average rate of change in the cost makes sense, just like a slope. Change in cost over change in the number of units that we're making, and that would give us the average cost per unit for however many units we were looking at there. Marginal. So whenever we talk about marginal functions in this section, we're talking about derivatives. If you think of your piece of paper in front of you, where's the margin? It's on the edge, right? So we use marginal to talk about the edge of the cost, as in how is it changing on the edge, right? Change happens at the edge of something, right? If you're growing, we imagine my height is increasing, so there's a change in the edge of me. I'm growing everywhere, but we talk about it as marginal because we're talking about what's happening at the edge, okay? So again, we could look at it as a limit of our average rate of change, or the limit as we do change in cost over change in the number of units, which of course, as we looked at in previous sections, is the derivative of cost with respect to the number of units. So c prime or dc dx. So this would be an instantaneous rate of change in cost per unit. So in this section, when we find derivatives, they give us an approximation. Now, because our cost function is a model representing the cost of producing how X units, it's already an approximation, right? It's not going to be necessarily 100% accurate. It's based on kind of studying, kind of producing this many, what did it cost, that many, how much did it cost, and kind of building a model from that. So already it's an approximation. So here, if we look at this first note, since X can usually only take on whole numbers, as in I can manufacture an entire car or no cars, but a fraction of a car is useless, right? So my X values often will have to be whole numbers in this chapter, because having a fraction of whatever this thing is I'm producing is typically a useless thing, and so we wouldn't consider it as something that's been produced. So because this delta X can't actually go to 0, it can only go down as far as 1, and it can't get smaller than 1. It can't get to a half or a third or an eighth or a 1/1,000,000th. So it can't actually approach 0 in that way. In that sense, this isn't entirely true, but it's still useful as an approximation. So we use it to approximate the change in cost between some units, well, here I'll just drag this out, between X units and X plus 1 unit. So in other words, it's going to approximate what would it cost to produce one more unit if I'm already making 100. So suppose I was making 100, what would the 101st unit cost? That's what my marginal cost will approximate for me. Yes? Well, it can be 0, but a limit doesn't have to actually reach the value. A limit says I'm getting infinitely close, and I can't get infinitely close to 0. Next bullet. So marginal cost is approximately equal to the average cost of producing one more unit. And the approximation for a large number of units is better than the approximation for a small number of units. So if I want to know how much it's going to cost for the second unit, marginal cost is not going to be super useful. If I want to know what's the cost for producing the 10,002nd unit, there it will be a pretty good approximation. Okay, so widgets. It's not uncommon that when economists or business-minded people are talking in generalities about producing something, they make up a name for whatever they're making. So a widget is a fairly common term used to represent something that's being made. So widgets are being produced at a rate of 1,000 units per day. And we have this cost function. We want to know the extra cost of increasing production from 1,000 to 1,001 units. What do? We what? No, actually. That's what we'll do. That's what we do for this question. Yeah, we're just going to do C of 1,001 minus C of 1,000. Which means we're going to do 0.005 x cubed minus 3x minus. So for this question, yeah, we're finding what is the actual change. And then we just evaluate. And you all have calculators. What is that thing? I don't know. That doesn't belong in this room. What are you doing using it? Yes. So you get about 15,000? All right. For number 2, we want to know the marginal cost when x is 1,000, which means marginal means take the derivative. So we'll do c prime of x, which will be and then we'll plug in the 1,000. And we get what do we get? And so the point of this was to show that when our numbers are fairly big, these two values are relatively close. The derivative? You're saying what? There's another 9 in there, so this is 15,000 and this is 150,000? I don't think so. Double check that number. Yes?
question one, we found out what's like how much more it costs to produce 1,000 units a day versus
Yep.
1,000.
Mm-hmm.
But then the cost to make 1,000 units itself is also around 15,000. Does that mean?
No. The cost to make 1,000 is this, almost 5 million. The marginal cost is close to 15,000.
Oh, so what we did is we found the actual cost of the
Yeah, so what we did is we did this much for question one, and we did this for question two, just to see the numbers are fairly close. They're not exact. The bigger the number would be, like if we did 10,001 and 10,000, it would be even closer together.
And the marginal cost is slightly different because we can't actually expect that.
That's right. So our change in the number of units cannot approach zero. It has to be discrete values. Yes. Yes, we will do that. Excellent point. So here, what should the units have been for number one? This would be dollars. What would the units be for this one? Dollars per widget, right? Because this is a rate of change. So here we just did a change in cost, so we know this is the change in cost for one more unit. No, because that was going to be this next question, what does a number mean? And that comes out in units. So you were reading my mind, which is great. But no, sorry, no candy. Yes. Number one. Oh, for a rounding to the nearest cent? Yeah, but often when we're not actually working with money, we'll keep more decimal places. Like you want your bank to keep all the 50 decimal places of your earnings so that they're being really precise and they're not robbing you. When they actually pay you out, they're going to round it off. But as long as your money is growing or shrinking or whatever, they're going to keep tons of decimal places. And kind of this is the in-process number, so we'll keep lots of decimal places. Yep.
So this one more basically $2,004.
Hey, what does this number mean? It approximates the cost of producing 1,001st widget, and it's about 15,000. The one more thing. Yep.
Oh, that's an additional. Oh, okay.
So, well, let's think back to this question. Suppose x was 1. This wouldn't be a particularly useful number because it's going to give me a negative cost. Yeah, that's weird. We should make only 1. So something that's not mentioned in this question is this model is only good for a certain range of production. And that's something that should be stated for a question like this, but it isn't. Yeah, good thing we highlighted that. But if we plugged in a different number here, like suppose you put in 2,000, then the number would change. Yeah, so the cost for that 2,001st widget would be different than the cost for the 1,001st widget. Yep. Because cost changes as I have a different number of units I'm producing. Right, so your costs may go down for a while, they may go up for a while, depending on how many things you're making, because you need to get more supplies. Maybe you have enough supplies to make this many, or you have to get more equipment, it's going to cost more. Or you have all the equipment you need, you have all the supplies you need, so cost is going to actually go down. So it's a cubic function, so cost is going to go up and down depending on how many things you're making. It's actual, but keep in mind, this cost function is always an approximation. It's not 100% accurate, but it gives the business an idea of what's going to happen. Yeah, we would word it that way. Yeah. Okay. Do you need a minute to chat with your neighbor to clarify things? You just want a minute to waste your time. Okay, take a minute. Talk to your neighbor, figure it out. Okay, demand function. So demand function is sometimes also called a price function. And in my head, it would make more sense to call it a price function. But for some reason, they call it demand function. I don't know why exactly. But it is a price per unit that a company can charge if it sells X units. Okay, so P of X might be called a price function, also called a demand function. But it represents price when you're producing X units, the price per unit. Yep. Well, because our revenue function depends on what our price function is. So if X units are made, the price per unit needs to be multiplied to the number of units we're making. And the price per unit may change depending on how many units we're producing and selling. But you want to be able to maximize your revenue, and the price per unit, you want to have some flexibility with it so that you can adjust based on, okay, how am I going to get the most people? So you want that kind of flexibility in what your price is going to be. Okay, on to marginal revenue, again, is derivative of the revenue function. So again, X times P of X, it's like X is the number of hamburgers. P of X is the price per hamburger. So you're just multiplying how many you're making times the price per unit. That gives you your revenue, which is how much money you're taking in. Okay, so again, the marginal revenue is going to be instantaneous rate of change. Instantaneous, again, it has to be approximate because you don't want to buy half or a quarter of a burger. You want the whole burger. So instantaneous rate of change in revenue with respect to the number of units sold. And again, it approximates the change in revenue when one more unit is sold. So here we have a bus company, offers a tour price for $15 per person, has an average demand of 1,000 customers per week. When they lower the price, so it could just be they did a survey and did research to kind of collect data, or they may have actually tested it out, lower the price for a week, and the demand jumped up to 1,100 customers. So we're going to assume that this price function or demand function is linear. We have 2 points. So you could use these 2 points, and we want to figure out an equation for this demand function. I think you could do this. This is like a grade 10 question. It is.
Oh my God, yeah.
So there's my price function. Any questions with my work there? All you grade 10 geniuses? Okay, we're ready for number 4? Oh, I'm waiting. Okay.
Oh my God, I didn't notice the running of the y-axis.
Oh, but price is a function of the number of customers. Yeah. Just a moment. I'm going to pause the record. Okay. Then we want to find what's the demand if the price is increased to 1650. So is this a P value or an X value? It's a P value, it's a price. Be very careful with those. So plug it in and solve for X. So suppose we increase the price to 1650. How many customers do we expect we'll get? We expect about 850 customers. Okay, making sense? It would be just because cost is typically a function of the number of units you're making. And so we want revenue to be a function of the number of units, which means we want price a function of the number of units. Yeah. Yes, Hassan.
So you start the X value or the cost?
No. X is representing the number of customers per week. Look at my scale here. So I define the variables on my graph, and then I use that for figuring out my slope and then the equation. Okay. Find the marginal revenue when the demand is 1,500 customers. Explain what it means. Marginal means derivative. And then we'll just plug in the 1,500 and you can explain what it means. So I'll give you a minute, do the calculation.
X times
Okay. Number 5. Everybody happy with my revenue function? Okay, so then we will take the derivative to find the marginal revenue function.
yes.
Okay, and then we'll plug in the 1,500 and we get -5. And then we have the question, what does this mean? I'm waiting for you to ask me about the units. Oh no, well, that was a Rob. Yep.
This means that if you have like 1,501 customers a week, you're gonna lose $5 in revenue every time you add one people.
Yeah. So if we add one more customer, our revenue is actually going to drop by $5 for that one extra customer, because our price function says if I'm adding people, I'm lowering the price. Now, are we actually doing that in real life? Like, oh, you're the next person on the bus, here's $5. No. But they have this model in order to help us set what is the best price we should set this at. So is this the best price we should be charging for tickets?
No.
So what should we be doing instead? What should we do with the price?
Increase it.
Increase it so that
Demand drops.
demand drops, we have fewer people, which actually will increase our revenue. Take a minute to think about what's a derivative?
Slow.
A slope of the tangent line. Our slope is negative. Our revenue function is a parabola, opens down. Where are we relative to our maximum? We're past the maximum. We want to be at the maximum to get the most possible revenue. Yeah. So here's how I put it into words. If we increase the number of customers from 1,500 to 1,501, the total revenue will decrease by about $5. When we have, marginal revenue of 0. That'll give us, which is partly why this kind of work falls under combinatorics and optimization, that branch of mathematics, because you want to optimize, as in maximize or minimize, whatever you're working with. So yeah, if we were to picture this graph, we have passed our maximum. Let's see. This actually should be at 0, 0, right? Yep. So we're somewhere over here where we have our slope. So this was at 1500. And here we're finding our slope is -$5 per customer. So back to the units, which I didn't put on this because I wanted you to think about what this means. Units would be dollars per customer. And this would be number of customers, and this would be revenue. Alien. Oh, I have a negative A value, so it has to open down. Right, so it curves down like this. Yep. Or if you think Math 31, negative leading coefficient means right end is down. Degree 2 means both ends are the same. Yes. You have to look at the scale, right? Now, as good as it sounds to maximize revenue, if maximizing revenue doesn't maximize profit, you don't want it. So you want to be able to maximize profit. So this is where we want to focus our attention generally if we had a business that we were working with. So profit is a function of the number of units, again. So X is always going to be the number of units. In our previous couple questions, it was a number of customers. In the questions before that, it was a number of widgets. It could be anything. Once again, marginal profit is the derivative of the profit function, and it'll be approximately the change in the profit by making and selling one more item, or taking on one more customer, that sort of thing. Question? Yeah, so here's where you have to be careful. This is uppercase P. Demand function is lowercase p, which is a really lousy letter to use because uppercase and lowercase can look so similar. So make sure you're really careful. All right. Demand function for a certain product is given there. And we have a cost function, which is also given. We want a profit function. How do we get the profit function? Yeah, find the revenue function first, which is x times lowercase p of x. And then subtract the cost function from it. Yes. There you go. I'll give you a minute. You can do the math. Number 6, anyone have questions with my work? So you're good with this profit function. We want to know profit when 0 units are produced and when 2,600 units are produced. What do? Plug in the numbers. So here we go. There's my profit function. And when nothing is produced, my profit is negative $10,000. Why? Yeah, because there was cost. You bought some property. You built a plant. You bought machinery, which $10,000 isn't much. So apparently, this isn't too much for a startup investor to put money into. There you go. When the company doesn't produce or sell anything, it's still losing $10,000. Okay, what does this number mean? Profit? Tell me more. That's just one word. Yep, so 2,600 units or whatever are produced and sold. We will have a profit of $52,400. That's a lot of things to make, but it depends what it is. Then we're going to figure out what's the marginal profit at 0 and 2,600. What does marginal mean? If we add one more, how much would that one more, how would that affect our profit? Because we're thinking, again, this is the slope of a tangent line. Where am I relative to a minimum or a maximum? So take a derivative. Dun, dun, dun. Simple function, nice. We can plug in the 0 and we get 50. Ooh, what does that mean?
That means you get $50 more.
Yeah, if I make just one thing, my profit is going up by $50. Then I'm only in debt $9,950. So you don't want to make just one. So if one unit was produced and sold, the profit would increase by about $50. So I didn't put units on the number because the units are what give meaning to the number, and I want us to explain the meaning in words. Yes, Hassan.
How is your slope though? So how is okay, so are you saying that
Yeah, it's saying if I produced and sold, that's where profit comes from, right? If I'm only producing and I'm not selling, then there's only cost. There is no revenue. But my profit function says the number of things I'm making is the same as the number of things I'm selling.
so does he make 1,400 products? You don't sell all of them.
Then you'd have to do a different calculation. So then you'd calculate cost separately from revenue. Yes?
So why would this be bad?
It's not bad. It's good. Yeah, but we're not in debt as much. We're $50 less in debt now.
Crazy bullshit. Let's say it was more than I get $100 more.
Yeah, there you go. Yeah, and by the time we get to 2,600, now we have this profit of 52,000.
But that's not your maximum profit, I think.
We'll have to see. As when we look at this, I'm getting a -2 for my marginal profit when the number of items I'm producing and selling is 2,600. So where am I at my profit relative to my maximum profit? I've passed my maximum profit. Gotta slow down. Or you need to change your model by somehow modifying your company, right? So if the company produced and sold the 2,601st unit, the total profit decreases by $2, which isn't much, really. Like $2 less than 52,400. $2 is like a McDonald's something. Is it $2 is well, half a coffee break? Well, depending on what kind of coffee you drink. There you go, 2 coffees. You and your buddy. You're the CEO and your buddy's the CFO or something. Okay, number 9. Find the value of X when marginal profit is 0. And figure out what that means. Okay, so I'm getting 2,500. What does that mean?
Maximum profit when you sell 2,500.
Maximum profit when I make and sell 2,500 units.
Just change it. You change the price.
Yep. So if your price function, that model changed, it's going to change your revenue function, which changes your profit function, which will change where it's going to be maximized. So whenever you make a change to your business model, how you're producing or how you're selling or kind of anything in between, your whole model changes, and so you have to recalculate. So hopefully you're getting the hint that you can expect me to quite frequently ask, what does that number mean? And with the application questions, sometimes it's challenging, but I expect you to be able to explain in words what the numbers mean, particularly when we take derivatives. And I think the next page is check your understanding, right? There we go. You can get started on that, and I will pick up your progress reports. Okay, number 10. So this is what the Keeb was working on while I was out, apparently. Weird. So in this situation, since every tie is priced at $60, it doesn't depend on how many ties you're selling. So that's why I have lowercase p of x for my demand function to be just equal to 60. There's no x in the equation at all, which means my revenue function just 60 times x. Good?
Yes.
Yes. That's the profit function, but this is the price function. So this is a lowercase p, that's an uppercase p. So be careful with the p's. So to figure out the cost function, I know the price, I know the profit function, I know the revenue function, so I can just subtract to figure out the cost function. There we go. That's my cost function. Good? So just do you understand the relationship between these 3 things? That's what the question is after. Next. Yes, the formula sheet will give you what? It'll give you this. Profit is revenue minus cost. And it will tell you that revenue is x times lowercase p of x. I think that's all it gives you. Or double check. Oh, there's also an average cost, but we skipped that section. So, yep, so those 2 things. All right, back to this page. Yep. Uppercase P is profit, lowercase p is price. Price per unit. We want to know the marginal cost and the marginal profit. And the shop makes and sells 5 ties. There we go. There's my marginal cost. which is negative 9.85. What does it mean? Well, the cost of making one more, the cost is actually decreasing because it's a negative. So remember, marginal is always a rate of change. A negative rate of change means the y and the x move in opposite directions. So as I'm increasing the number of units, I'm decreasing the cost in this situation. Halian. Lowercase p is called the demand function or price function. It is the price per unit. Yes. Is profit, which is, nope, overall profit. So my marginal profit is $69.85. What's the relationship between these two numbers? Inverse? Not quite. What's this number? Negative 985. What's this number? 69.85. How much are you making? How much are you selling each tie for? $60. How much more? Well, how much has your cost decreased by for one more? That 985, or I should say $9.85. So there you see the connection between those two because my revenue function is well, not a constant, but my price function is a constant. Questions? Yep. We were given a profit function. Alian, you had a question. Derivative of cost is marginal cost, which is the marginal cost when I have 5 ties, means that's the approximate change in cost for making one more tie. So it's saying when I make the 6th tie, the cost is going to go down by $9.85. The cost per, or I should say the overall cost for production. Shh. Say that once more. Yep. My profit increases by, my total profit increases by $69.85. Yep. The reason is because my cost decreased by $9.85 and selling one more tie gave me $60 plus that decrease in cost. So my total profit goes up by the $9.85. Yep. Because marginal, when I plug in a number, it's saying at the margin of 5 is like one more. So that's for the 6th tie. Yep. That's an approximate, in this case, cost or change in cost for one more unit. Yep. Italian? Can you pause for a second? Ethan and Rizwan, can you guys stop talking, please? Thanks. Go ahead. We don't do marginal prices. Yep. Number 13. What is the marginal cost and the marginal profit when the shop makes and sells 30 ties, and explain what each means? So now my marginal cost is $45.40. So the cost is going up now at this point. And my marginal profit is $14.60, which means my profit is also increasing. Yes.
Talking about cost, again, so does it mean that price of the ties is like increasing like the price of the set is decreasing, or just the total cost of all the stuff?
Well, the price that we're selling ties for isn't changing. We're keeping that at $60. Pardon me? Cost means as I'm producing, what's happening to my costs. So when I produce one more tie, even though I'm going to sell it for $60, it's costing me $45.40 more for that one extra tie. Exactly. So you can see that these two add up to the $60 again. Let me just pull out the last one. So it'll be on the video for people at home, and you can see it. And there you go. Last ends. Yes, because you're starting to lose money. Well, you're not losing money, you're just making less, which is really important. Keep in mind that a negative marginal profit does not mean you're losing money. That's a mistake lots of students make. It just means that your profit has decreased. You're still making profit, but you're just not making as much as you were by making and selling fewer ties. Okay, you're free to go. Thus ends the lesson video. Goodbye, people online.